All right, so we're going to finish up question 18 right now. So we have this box being pushed at I made a little typo here. We're pushing this box, and it experiences an acceleration of 2 meters per second squared. And what this means is that the forces are in fact unbalanced. So let's go ahead. We have Fn, we have Fg, we have the applied force from the girl, and we have a friction force going backwards. So let's set up our unbalanced force equation, horizontally unbalanced because it is accelerating. So we have Fa minus a 42 Newton friction force equals 15 times 2. And when we isolate, we're going to end up getting Fa, the applied force, the pushing force from the girl, is in fact 72 newtons. Now let's take a look at part B. In part B, very similar idea. Just to be safe. So this is our free body diagram. It is the same. Also, just a small point here, since students like this labeled. Yes, these are balanced. However, Fa and F are not. So horizontally, we are still unbalanced, but now we have a smaller acceleration. We have the same 72 Newton force, but we're unbalanced still, and we want the new friction force. So I can actually take the equation here, and I can say 72 newtons minus the friction force, which we're trying to solve for, is 15 times 1. And when we isolate, we're going to get a friction force of 57 newtons. We want the speed of the box after 3 seconds, assuming the acceleration is what it was in part B. So we have 1 meters per second squared for the acceleration. And this is a SUVAT question. So we have S, U, V, A, T. So S is unknown. U is, we'll assume it starts from rest. And then V is what we're solving for. Sorry, I already wrote A up there. And then T is going to be our 3 seconds. So V is AT plus U. V is going to be 1 times 3 plus 0. So we're getting a final speed of 3 meters per second. Again, I tend to use speed and velocity interchangeably in these problems because we're moving in one direction in a straight line. Now for part D. Let's do a new free body diagram. So we'll have the normal force, and we'll have the weight force, these balance, and friction is slowing us down. So we have an unbalanced friction force, which we always subtract, equal to ma. So first we're going to get the acceleration, and then we're going to use this. We're doing it literally with the directions, say here, determine the acceleration, and use this to find the time it takes the box to come to rest. So we have negative 57, that comes from right here, equals, and just to be clear, we're going to use this in D, so I'll just say used in part D2, okay? So negative 57 equals 15 times A, and so we're going to get A is negative 3.8 meters per second squared. Finally, we're going to get the time it takes to come to rest. So V is AT plus U. 0 is negative 3.8 times T plus 3. And when we finally isolate T, we are going to get a value of 0.79 seconds. So that is part D. I want to say one last thing regarding the extra credit. So first, these need to be changed to 240. And also here, just to be clear, the reason it's extra credit is that I'm not helping you with it because I really want you to have that experience of trying to figure it out and doing a little bit of the work on your own. So it's extra credit because I'm making you work for it. Okay? So I'm going to leave off there. And then the last thing is none of these extra practice problems appear on the test. Those were put there for students that felt like they wanted to push themselves a little bit harder in the realm of understanding forces. So that's it for the second practice exam, and I'll have those solutions up now.